In this example, we're going to look at an example for a non-metal atom, a non-metal. So we're going to be looking at oxygen. And oxygen is here. And we can see that oxygen's to the right of the stair-step line where the non-metals are. We also are reminded that non-metals like to gain electrons. Each one of the energy levels has a full outer energy level. Energy level 1 is full with 2 electrons. Energy level 2 and 3 are full with 8. We haven't discussed 4 through 7 yet. Remember, there are only 7 energy levels corresponding to the 7 rows on the periodic table. And so right now we're just dealing up with rows 3, and we're also only dealing with the A columns. We're not dealing with the B columns in the middle or these final 2 rows. So when we look at oxygen, it's in this area right here with the nonmetals. We would expect oxygen to want to gain electrons in order to have a full energy level, because oxygen's a nonmetal, and in general, nonmetals like to gain, metals like to lose. So when we look up oxygen, we see oxygen is number 8 on the periodic table. So we're going to draw it. 1, 2, 3, 4, 5, 6, 7, 8. 8 protons packed tightly together in the nucleus of the atom. Very, very small compared to the size of the atom. Oxygen is in row number 2, so there are 2 energy levels. Surface of a ping pong ball, surface of a tennis ball, where the electrons are flying around in those areas of space. The very final energy level, oxygen, is in column 6A, which indicates that there are 1, 2, 3, 4, 5, 6 electrons on the outside. That's what the 6A means. 6 electrons on the outside. So how are those 8 total electrons distributed? We walk through the periodic table. We start with row number 1 and we count over 2. So 2 electrons in energy level number 1. Then we go to energy level 2 and we count over 1, 2, 3, 4, 5, 6. 6 electrons in energy level number 2. That is an atom of oxygen with 8 protons and 8 electrons. 8 protons in the nucleus, 8 electrons distributed or arranged in the electron cloud. The charge of oxygen, it is neutral. There is no charge because it's got the same number of protons, same number of electrons. How many valence, how many outer, how many bonding electrons does it have? It has 6 on the outside, 6 electrons on the outside. Would it make more sense for oxygen to gain or lose electrons? The last lecture I talked about metals typically have 1, 2, or 3 outer electrons. Because metals typically have 1, 2, or 3 outer electrons, they're going to be losing electrons in order to have a full outer energy level. Whereas non-metals typically have 5, 6, or 7 outer electrons. So they're typically going to be gaining electrons. Someone's going to say, well, what about if we have 4 outer electrons? 4 outer electrons is half of this 8. What if we're in this section we have 4? We're going to find out later that these types of atoms typically like to share electrons. And then someone's going to say, well, what if we've got 8 outer electrons? Then these don't gain or lose or share. They don't want to do anything. That's why we call them the noble gases. They are very unreactive. They don't like to react with any other atoms. So when we go back to our problem, would it make more sense for oxygen to lose or gain? Definitely gain. It already has 6 electrons on the outside, and it only needs 2 more. So, how many electrons need to be gained in order to fill the outermost energy level? Well, it already has 6 electrons, so it's going to gain 2 more. 2 more electrons. When it gains, it will have 8 on the outside, and that's what it's trying to do. So, let's draw a picture. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Same number of protons. It did not change. Also, take a look at this. The number of energy levels did not change either. We still have the 2 electrons in energy level number 1. We still have those 6, 1, 2, 3, 4, 5, 6 electrons in energy level number 2. And now we're gaining 2 more electrons. 2 more electrons to have a full outer energy level. Non-metals like to gain in energy level number 2. We want to be full with 8 outer electrons. Now it's full. So this is still oxygen, but it has 8 protons and 10 electrons. It's got 2 more electrons. Why does it have 2 more? Because they originally started with 6 on the outside, so it gained 2. So now it has 10. So we write it as an O2 negative because there's 2 more electrons than there are protons. We change the name to oxide. That's very important. For non-metals, we change the ending of its name to IDE. So instead of oxygen atom, it's called an oxide ion. How many protons does it have? It still has 8 protons. It did not change the number of protons. Those are protected on the inside of the atom. How many electrons does it have? It now has 10 electrons because it gained 2, so that it would have 8 on the outside. What's the overall charge? 2 negative. What are some similarities between the two? Well, similar. They both have 8 protons. What else is similar? The number of energy levels. The number of energy levels did not change. But what is different between the two? What's different between the two? The charge is different. The name is different. We changed it from oxygen to oxide. This ion is a little bigger than the atom. Now, someone's going to say, well, but wait, Mr. Hodges, there's 2 energy levels here and 2 energy levels here. Yes, but because there are more electrons here, these electrons are repelling each other because they're all negatively charged. So when you come in, when these extra electrons come in, they repel each other, so that second energy level expands a little bit and gets a little bit bigger. It's like up here if you were sitting with 5 of your friends, 6 of you at a picnic, and 2 more friends came in, you're going to spread out so they can fit into that area of space. And so the ion is actually just a little bit bigger, not because it gained an energy level, it didn't, but because those negative electrons repelling each other spread out away from each other a bit. I hope this helps in understanding the nonmetals gaining electrons in order to have a complete outer energy level. Now, what does oxygen look like on the outside now? Well, who has 2 energy levels with its 8 electrons on the outside? 2 energy levels with its 8 electrons. Second energy level with the 8 electrons would be neon. So, in the previous worksheet, we said that sodium losing an electron on the outside looked like neon, and now oxygen gaining electrons on the outside looks like neon. So the way that we would write that is we would say that the sodium ion, the Na+, looks like the oxygen ion, O2-, and looks like neon atom on the outside. Only on the outside. All three of these. So look at sodium with oxygen with 2 energy levels, 8 electrons on the outside. Sodium, 2 energy levels, 8 electrons on the outside. And then neon, 10 protons, energy level number 2, 10 electrons, but 8 of them on the outside. All three of these look similar or the same on the outside. I hope this helps in understanding the process of atoms losing or gaining electrons in order to turn into ions.